Now let's address the elephant in the room. What the heck is the first law of thermodynamics? Or in other words, the law of conservation of energy. Now, the definition of this is energy cannot be created nor destroyed during chemical reactions. The total energy constant of the universe remains constant. Now, if you've ever taken a chem test and had points taken off just because you didn't say during chemical reactions in your definition, that's not your chem teacher trying to be a devil.
Let me tell you something. All right. Let me tell you something.
There is actually a point behind this. The reason is, the first law of thermodynamics is assuming, in this case, that the only thing happening that affects the energy content in the world is just chemical reactions. Obviously, that's not true. So, don't get too mad about that. Now away from the tangent and back to the point, there's many types of energy in the world, as you see in my other video on energy: kinetic, electromagnetic radiation, electrical, gravitational, whatever. The two main ones I want to focus on, however, are kinetic and potential energy. In relation to the law I just told you about, any given quantity of potential energy can be changed into the same quantity of kinetic energy. What's kinetic energy? It's the energy of motion. What's potential energy? Energy due to position, as in the physics definition, or composition, in the chemistry definition. Basically, in a nutshell, it's stored energy that has the potential to do something like moving an object or heating something. That's the potential in potential energy. Here's a marker. It's on the table. Technically, this isn't the closest to the center of where gravity is trying to take this object, for example, on the floor even, which is not the furthest, but close enough. But for the sake of this analogy, let's pretend that when this is on the table, that is zero potential energy. What about kinetic energy? From a physics perspective, no, there's actually just zero kinetic energy. It doesn't have any kinetic energy because the marker isn't moving right now. From a chemistry perspective, yeah, there is kinetic energy. The particles are moving, even if only slightly, since it's a solid, but they are moving because it's not at absolute zero. But let's move on with this analogy, thinking from the physics perspective. So zero kinetic, zero potential. Okay, with that out of the way, let's get right into it. When the marker is up here, it's high potential energy. When it's down here, it's low potential energy. Now what if I just drop this marker right now, which aka it's from the point of high potential energy. As it goes down, the potential energy goes down as this marker goes down. But hold on, that can't just happen, right? According to the first law of thermodynamics, the energy total constant must be the same. Something else must be happening too. Some other form of energy must be going up by the same amount. The answer is yes, kinetic energy goes up to make up for this loss in potential energy. So as there is less and less potential energy, there is more and more kinetic energy. This, my friend, is why when you drop things, they get faster as they fall down. Okay, great, but once it's done falling, now what? Zero potential, zero kinetic? That breaks the law, doesn't it? No, it doesn't. Let's rewind for a second. Listen carefully. Did you hear that? Sound energy. Not only that, but let's say I drop something heavier and from a farther place. There'd be probably a dent in the table. Why? Because the energy would have transferred into the table. So no, that energy didn't go from high kinetic, low potential to zero both and that's it, because that wouldn't make any sense. It was converted to sound energy and other types of energy. Thus, the first law was never broken. Okay, now one last thing that I haven't addressed. What if I do the opposite? What if I picked it up? So it's starting at zero potential, and increasing potential energy as I take it higher. But there's no kinetic energy changing here anyway. So then where's the energy making up for it? There's no sound energy, none of that. The answer is, I'm the one who's losing energy. By picking this up, I'm putting the effort into carrying it higher. This may not seem evident since it's literally a marker and I'm, very strong and buff and everything, so it doesn't make a difference to me. But if I was picking up something heavier, it'll probably be more obvious. But even if I don't realize that there is energy being used here. So the point is, the law was never broken. So that's the first law of thermodynamics in a nutshell with regards to kinetic and potential energy for you. So thanks for checking out Nab's Lab, and until next time.
Clock strikes 12. Midnight arrive.